store at different times of day. And that kind of helps managers decide when they need to do staffing, things like, you know, opening and closing hours, things like that. Another way that laser particle counters are used are in traffic management, like on roads. Cities will set up laser particle counters. The particles in this case are cars, and as the cars break the laser beam, it counts how many cars are on a road so that you can tell if the street's busy, does it need a stop sign, does it need traffic lights, just a bunch of different things. Do we need, what are those little bumps called that slow cars down so that they don't go too fast? Anything like that. And then the third case that I chose to highlight was an air quality sensor. In this case, the particles that the laser particle counter is counting look like PM10s and PM3s, and then it does some math and comes up with a rating for your air quality for that day. In each instance, the basics are the same. It's a laser that you're shining to a sensor, and then particles are breaking that laser beam, and you're counting how many particles are breaking the laser beam. So let's get to the fun part, and let's start building. We need a breadboard, Arduino, some jumper wires, let's see, a OLED screen, the photoresistor. I don't know if you can see that very well. And then a regular resistor, and your resistors might look like this out of the box. You can just pull it right out, bend the legs down, and you're ready to use it. And if I were teaching this in a classroom, I would probably get all of my supplies ready. I wouldn't hand the entire Because Learning kit to each of my groups of students because there are so many other things that we're not using for this experiment. I'd probably have a teacher's aide or something go through and just get all of the supplies ready, and then I just pass those out to each of the groups. Okay, let's start with the Arduino. Let me get it oriented right. So from our diagram on my screen, we need 3 wires. We need a red wire, and color doesn't really matter. The color is just, traditionally we use the red wire to come from the power. And in the wiring diagram, that's exactly what it is. The red wire is going into the 3v3 port. And then black usually stands for ground or the negative. And if you'll notice on your Arduino, you have 2 negative ports, 2 ground ports. And it doesn't matter which one you choose, just as long as you choose one of them. And then in this case, we have a blue wire that also goes into the analog 0 pin. All right, so I've got my wires on my Arduino. And now I'm going to switch to the breadboard. It's important to understand how the breadboard's laid out before you start building. So if you notice, we have 2 rails on the side, kind of flappy. They come apart from the main breadboard. And these rails are actually, they have a bunch of little holes. And there are 2 columns of holes actually. And on the rails, the columns are connected. So anything you plug into a column will be in your circuit. On the inside of the breadboard, it's the opposite. All of the holes are connected in rows. So anything you plug into a row will be in your circuit as well. The only exception is this there's a little gap right here, and you actually have to bridge from one row to another across the gap. But that's not actually, we're not going to use that in this experiment today. We're only going to use one rail and one side of your breadboard. So columns are connected on the rails, rows are connected on the inside of the breadboard. Okay, do you notice that there's a positive and a negative on top of the rails? We are going to use that for our positive and negative wires in our Arduino. Now in my diagram, I'm going to take my red wire here, my positive connection. In my diagram, it looks like it's about on hole 11, the 11th row down. Remember, all of these are connected in a column, so it doesn't matter where I put it in that column, just as long as I get it in somewhere in that first positive column on my breadboard rail. Okay, Negative is the same thing. In my diagram, it shows it right next to the positive on the breadboard, but it doesn't really matter. I can put it anywhere in that second column because rails are connected by columns. Okay, I'm going to leave the blue wire for last. I'm going to move to my photoresistor. In the diagram, my photoresistor, it looks like it's about 3 rows down from the top, and then it bridges over to the middle part of the breadboard. All I need to do is make sure that one of the legs is in the first column of the breadboard, and the other leg bridges over to one of the rows. Okay, and I've noticed when I taught this with my students, they're really delicate with the pieces, and if you just kind of rest your photoresistor on, it's not going to make the full connection. You really need to give it a little bit of pressure, not enough that it bends the legs, but just enough so that it slides into place and gets a really nice connection for your circuit. Okay, regular resistor. In the diagram, remember position doesn't really matter. It's just that one leg needs to be in the second column and the other leg needs to be in the same row as the photoresistor. So I'm going to put one leg in the second column. The other leg is next to the second leg of the photoresistor. All right, the blue wire. It needs to be in the same row as the resistors. Doesn't matter the position, really, just as long as it's in that same row as the resistors. And while I was building this with students, there's a lot of room for error with students plugging things into a breadboard. You could get one pin off just by one little connection and the whole circuit won't work. So this is a great area to like stop, troubleshoot. I usually like to have somebody wire up the circuit and then I'm like, okay, trade with your partner in your group and have them check it. Make sure everything's in the right spot. Just to make sure we troubleshoot before we even get started building. I forgot one thing on my Arduino, and that was my OLED screen. So you have 3 Grove connectors here. Top one is the only one that won't work with the OLED. Either of the bottom 2 will work. So I just plug it right in, and you kind of want to make it snap so that it goes in firmly. I noticed some students didn't push it in all the way as well there too. Okay, I'm ready to go. I need to give it some power, and then I need to run my sketch on the Arduino so that it knows to act as a laser particle counter. So I'm going to use my USB cable. One end gets plugged into my computer, one end plugged into my Arduino. And you should notice nothing on the OLED display because we have to put a program onto the Arduino so that it knows what to do. So no panicking yet. All right, I'm going to scroll down on my computer screen. And here is the sketch for the laser particle counter. I am going to click, well, first of all, there's a little light right here that tells me my Arduino's, it's green, tells me my Arduino's getting power. It's on, so I'm good to go. Now when I press run on Arduino, I should get some blinking lights down here. And that tells me that it's compiling a program, it's perfectly normal. And then I get that successful program message in the corner of my web browser. All right, let's check the screen. It looks like it is at 0, the starting point, perfect. Perfect. Now what we need to do is calibrate our laser particle counter. This is the hard part because everybody's room where they're building their laser particle counter has different amounts of ambient light. So what we need to do is figure out what your high level of light is and what your low level of light is. And then we need to find a median point so that the counter knows when to start, when a particle is blocking the laser beam. So when I was building this circuit, I noticed that if you orient your photoresistor this way, I notice it kind of looks like a sine wave in the photoresistor. And if you orient it as a sine wave, that's able to detect the laser better. So I'm going to move my computer screen down so that you can see. I'm going to grab my laser pointer. And this is just a test, right, to calibrate how sensitive my photoresistor is. Okay, so I shine the light on there, and when I block it, I should increase by 1, but I'm not. And that's because I have a lot of lights on for this webinar in this room. So I'm going to go back here to my web page, and I'm going to click this little button right here, and that's going to open a serial monitor. The serial monitor is going to give me the light readings that they are sensing, or it's not. It's going to give me 0. Okay, that's okay. This is a problem you could run into in the classroom as well. So I'm going to check my connections really fast. And then I'm also going to refresh my browser. Bring up that serial monitor again. Still nothing. I'm going to try a new photoresistor actually. All right. We swap out. Okay, let's check our serial monitor. Great. Okay, so when I don't have a laser pointer shining on the photoresistor, I get about an 820 luminosity value. And when I shine the laser pointer on the photoresistor, it bumps all the way up to about 1,000. Well, it was almost perfectly 1,007, right? So what I need to do is figure out a median point between about 800 and 1,000. So a median point would be about 900. So I'm going to close my serial monitor. Line 26 of the code. If the photoresistor value is less than 500, that's way too low for my lighting in my room. If you remember, I calculated the median to be about 900. So I'm just going to click right in here and change it to, whoops, 900. Edit the code right in line. Okay, the Arduino doesn't have the information yet, so I need to compile it again. Run on Arduino. I'll see the lights flashing, saying it's getting the new program. Okay, success. Let's see how we did. So here's my counter, my laser. Oh. And every time I block it, I'm increasing my particle counter. Perfect, I'm up to 8, great. Okay, so now that we've got it calibrated for the lighting that it's in the room, you can put it on anything you want. I had it on a ramp in the GIF at the beginning of the lesson, and it counted cars as the cars broke the laser beam. But I found, see, I'll move my camera up, tissue box. How many people take a tissue out of my tissue box? You can set up your laser particle counter, and every time somebody goes to grab one, whoops, if it doesn't pop up, it'll count it. Something like that. How many times somebody opens the fridge door, how many times somebody goes into the classroom or out of the classroom. Things like that are all great ways to set up the laser particle counter. One thing that is really helpful is having a laser pointer, again, that has the switch so that the laser pointer stays on all the time. I have these other laser pointers with a button. And they were so hard to, you have to press the button down, you have to tape it in place, you have to tie the button down somehow to keep it on for the laser particle counter to work. So having one that switches on and switches off is a really great improvement to make for this particular engineering lesson. Are there any questions?
We do have a couple questions here.
Perfect.
We've got some great guests from the Houston Space Center.
Oh, fun.
Came a little late, and they asked kind of, is this a lesson? So maybe you could just recap. This is a lesson that's in our curriculum?
Yes, this is a lesson that's in our curriculum library. Just once again, the way to get to our curriculum is lessons.becauselearning.com. That'll take you right to our curriculum page. And we have everything bundled into units. So you can kind of see the groupings of different lessons. You can select up here which sensor you want to use. You can select grade level, subject area, or you can just search. This is the laser particle counter. And we have a lot of laser lessons, so laser particle counter happens to be in this high school unit. Just click on it and it takes you right to the page, to the experiment page.
And there's a question from Lisa here that I can just answer. So Lisa, it sounds like you might be missing a part in your kit, having to do a USB cable.
Oh.
If you give me an email at kevin@becauselearning.com, I'd be happy to chat with you and see if we can get your kit back up to
perfect,
stocked up.
Perfect. Oh, I was going to mention, since you brought up the USB cable, one way to make this, once you compile the code onto your Arduino, you can totally unplug it and make it portable by attaching the battery clip with a 9-volt battery. And that way you can put it, like on your classroom door or the fridge, and it runs off of a 9-volt battery and makes it completely portable so that it doesn't have to be connected to the computer.
And let's see, we have one other question was, can we use another sensor, like a sensor that might be on the spaceport?
What an excellent question. So this is our spaceport that has 8 sensors on it. And we have a luminosity sensor, in particular, a light sensor on this. You could totally replace, we happen to use the photoresistor in our circuit, but you could replace it with one of the sensors on the sensor board, like the light sensor. You could use the UV sensor with a UV light. You could use the RGB sensor. You could use any of those things, and that would be a great challenge for students to be like, okay, now you've mastered this circuit. How can you integrate the sensor from the sensor board into a laser particle counter of some sort? Great questions.
And then, are there any other common problems that might come up during this?
Totally. There's lots of common problems. Sometimes I've noticed that my students aren't particular, like they don't know the columns and the rows, and they just kind of plug things in anywhere. You really have to be careful. That's the first place I always start if somebody's circuit isn't working. I look at their breadboard and I make sure that everything's wired up correctly. Another common problem is that the labels on the Arduino are really small, and you kind of have to count down the number. You have to be careful about the groves and how you stick them in. And sometimes students will just willy-nilly put them in wherever, or it's off by 1 and it makes a huge difference in your circuit. So those are great things to check. I'm trying to think of. And like I said earlier, I really like to have somebody in the group. I like students to work in pairs or 3s. And then I like to have somebody wire it up. And then I like them to pass it off to their partner, and they double check it to make sure that it matches the wiring diagram. And a lot of errors will be caught that way. Sometimes you'll get a student whose circuit just won't work. And if you have another student or another group in the class who has a working one, another great idea is to be like, okay, you guys collaborate. There's something wrong with this. Theirs is working, yours isn't. Figure out the problem. Those troubleshooting skills are really a great thing to learn in the classroom as well.
We've got a question here having to do with, if Arduino gets warm, or we've got a couple here that are not working. Yeah, if you have any issues with your Arduino, you can give us anytime you can reach out to us at support@becauselearning.com, or this is Kevin speaking. You can direct email to me also, kevin@becauselearning.com. Support@becauselearning.com is a queue that gets worked by a support team. There are commands in the code that the students can adjust. I don't see where you're putting the wires in the wrong place. It is us. Oh, okay. Oh, I don't know if we're putting wires in the wrong place. I think this is us. Okay, so the control. Without being able to see that breadboard, I don't know if I can answer that one, but that might be one yeah, just if you have somebody that's working for somebody's and not working for somebody else's, you can kind of compare your circuits. So it says, are there other commands in the code that the students can adjust?
Oh, yeah.
Yeah, so
Would you like to?
Yeah, sure, I can look at this one. So
Okay.
I guess the one when I look at here is the photoresistor value. That's kind of probably the biggest adjustment one here for calibration. So that's that if photoresistor value is less than 500. And then the other one that they could, if they wanted to play around with, would be, I guess they have a serial print line here. So you could print something else maybe. Right now we're just printing that value, but we could put in a label. There's not a whole lot for this particular example for editing. You might want to look at the coding unit in our lessons for something that's a little bit more coding specific.
And that coding unit shows up right when you go to lessons.becauselearning.com. That's one of our featured units right here. A bunch of different coding lessons, a bunch of opportunities for the students to change different pieces of the code.
If anybody has any more questions, you can just drop those in the chat. Or if there's any, like support related questions or anything in general, you can always send those to support@becauselearning.com.
Absolutely. So we've worked out a few, with our sales department, we've worked out a special discount code that we'll be sending out for anybody who wants to try, who's attended our webinar and wants to try the kits, and I will send that out shortly and get you guys information on the discount. Are there any final questions?
So, so Lisa, it looks like you're not having any luck there.
Oh, darn it. I can actually see your video, Lisa. Can you hold up your...
Hey there. How far are you and what doesn't seem to be working, Lisa? So the USB cable should, yeah, it should just go into there and then into your computer. We kind of, let me see if I can pull you full screen and then I'll be able to see. Yes. Okay, so that part right there.
Oh, here, let me.
Sure. So you're going to want to put that right in here. And that's a micro USB connection. That's kind of like common for like an Android phone. Oh, that one will go, so the OLED display, that will go right in here. There's only port that doesn't work, and it's plugged up when we send out of the factory. It'd be any of those two should work. And it only fits in one direction. So we got a question, can you repeat the calibration steps?
Absolutely, I'd love to. Okay, so I have my circuit hooked up and I want it to be plugged in to the computer. So I'm going to attach the USB cable to the Arduino and the other end into my computer. Let me find my lesson.
And Lisa, you'll need to flash your program there, just kind of like Lindsay's doing on that lesson. You'll need to load the program on there in order to see the data. So you have to load the program.
So I'm gonna, by running on Arduino, press that button. And you'll notice some lights flashing on your Arduino. It's receiving the program. And then the code successfully uploaded there. And I'm gonna tip this down. Okay, I'm gonna open this serial monitor. That's this little button right here. And that gives me a reading from the photoresistor. So right now, just the ambient light in my room is around, oh, like 800, it looks to be. I think the high point is like 810. And if I shine my laser pointer on the photoresistor, it bumps all the way up to about 1008. So laser pointer is about 1008. Ambient light is around 800. So I'll just round that. It's between 800 and 1000. Low is at 800, high is 1000. So I'm going to take a median, a midpoint of that, which is going to be 900. And everybody's readings are going to be different based on the light that you have in your room. Okay, so I am going to go back to the code. Right here, line 26. If photoresistor value is less than 500, and I calculated my median point to be, I think it was 900. So I change it right in there. And it won't work quite yet because I still have to run it onto my Arduino. So I click the Run on Arduino button. Lights are flashing. There we go, successfully uploaded. And it should work. Let's see if I can. So there's with the laser. And every time I block it, it should increase the count. Perfect. All right, so that runs you through the calibration a little bit. Okay, well, you can send your questions to me, Lindsey at becauselearning.com. You can send them to Kevin at becauselearning.com, or you can send them to our support line, which is support at becauselearning.com. Or you can just reply to the email I'm going to send out with the discount information. And we'd be happy to help you troubleshoot your circuit or get you started. Again, we appreciate your time, and I hope you get as excited about the laser particle counter as I do. Have a great day.